She's currently CEO of LaunchBox.
Yeah.
She'll be talking about LaunchBox today. LaunchBox is one of the partners in the Delta V initiative, which UNSW and AXA are involved with as well. I don't know, are you going to talk about that, or are you going to talk about?
Yeah, I'm going to talk about LaunchBox and several things we do in the company here.
Okay, anyway, I don't want to ask what you're going to talk about, let's just listen to what you're going to talk about.
Okay. Hello everyone. Sorry I was a bit late. Virgin fault. Not mine. Let's blame someone else. Okay. Let's go to the presentation and chat about a bit of stuff, okay? So LaunchBox is the name of the company. I'm currently the CEO. And this has been a pretty tough year. So LaunchBox has been founded 1 year and more, 1.5 years ago. And it's been a very exciting year, very interesting, and I would like to share with you. For the students, I've been maybe to inspire you, give the best of what you are doing because you have to. I'll tell you about my story and how I got stuck during the thing I was doing, and then I started thinking. Thinking is a powerful resource. For the others, more to tell what's happening in Australia because we are busy with interesting stuff. This company started from me, and me is this. I really love space, okay? So I'm Italian. I know I don't sound Italian, I sound very English, but years and years
Your
of lessons.
flair gives you away.
Exactly. But I loved space. So space was my thing. Since I was little, I really was building little rockets and doing such a disaster in my house. I live in a flat, you know, in Rome, so I was doing rockets in a park in the middle of Rome. It wasn't that perfect, and I wasn't that good, but I didn't give up. I really like space, so I studied aerospace engineering, and then I moved to Holland, the Netherlands. We have a Dutch there, so I don't have to talk badly about that country. And I love it, okay? I was there for 7 years, and I started working at the European Space Agency. I was 24, was a big dream. And I kept doing this for quite a lot, okay? So I was 23 when I started working there. And my background is engines, so I was doing propulsion systems. Propulsion systems for small satellites and for big launcher. So small satellites was mainly CubeSat. So when I was 23, I started working on CubeSat, and I thought, wow, this is interesting. And on Vega. So all mission system for Vega, Vinci, and all kind of big engines, okay? I like both. But I got very, very excited by this capability of this CubeSat. Then I found a job in this company in Holland. That was the best 5 years of my life because I really did quite a lot there. And we had the chance to really do amazing stuff. I'm a big nerd. I got 3 patents on micropropulsion. I really, really like it. Really like it, it's my dream. And CubeSat, I think you guys know, everyone knows what we're talking about in this room. So far it's been really a game for university. This is what it's been so far, okay? So not a lot of companies or universities really focus their attention on the micropropulsion system. That is a big deal because we are talking about little satellite, okay? And propulsion systems usually are pretty intensive and complicated systems, okay? This is what I've been doing for 7 years. I like space, I like working in space, but space is an absolutely traditional machine, okay? So everything happened, hey, let's take it easy, we have to do a lot of reviews, a lot of things, and you know, we are not really going through to do things if you are not sure of what we are doing. Space is like that, at least space in Europe is like that. Everything takes quite a lot. I always bring this example, you know, this little propulsion system is the first one that flew on European CubeSat mission. It took us 10 years, like something like 5 million euro. It's crazy. It worked, okay? But during those 10 years, I arrived, let's say, at year 3, okay? Requirements change, they do change, okay? We started working, like, Europe is a funny place where a lot of space happening, okay? We started working on an engine that was called Score D. But a lot of industry in Europe started fighting with it. So after 7 years and 20 million spent, they stopped the project. I was in this machine and I thought, is this possible? Is this the way space is? You know that we spend money and money and money, and people change idea all the time. But you know, I say, whatever. And then happened that I came here. I came here a couple of years ago, 2.5 years ago. So I left all those amazing activities, and this guy old, okay? He's cute. So I said, whatever, let's do it. I met him, we were working in Europe, and he's from Adelaide. Adelaide, of all the cities, he's from Adelaide. I didn't know where Adelaide was. Now I know, I live there. He loves Adelaide, he's not gonna move. Family was a priority for me, so 3 years after I came here. And that's where things really changed for me, okay? Because I'm 31, so I'm pretty young. And for 7 years, the last project I was doing before coming here, Microtrust was a consortium of eight countries. I was the project manager. It was a 5 million project, and we were launching satellites to Mars, asteroids, and it was amazing, okay? When I came here, what I had in front of me was different. And I had to reinvent myself. Reinventing myself was hard in the sense that, what do? Do you just change job, or do you actually start thinking? And I start thinking that actually, with all the consideration I've done in the past about how space is a big machine, you know, and see that Australia has got little things in space, but not a big, formal, amazing industry, I start thinking, why don't we use space in a commercial way? Because you know, guys, everyone knows in this room, most probably the students less, the space is changing, okay? There are people in this world that are using space in a powerful way. They're all in the United States, most probably. But we are talking about guys that you can easily Google it, you know, like Richard Branson, Elon Musk. Hey, this guy are making a lot of money using space as a commercial activity. And not just that, but changing the way space is done, changing the speed. Okay, they've got a lot of money, and we don't. But that's not the point, it's the approach, okay? I really like it. I got together with some people. This is me, and this is Matt. So Matt and I are in Adelaide, and we are working on the QB50 mission. And Matt, at the end, right hand, is here in Adelaide. He is currently my CEO. He doesn't know much about space, but he knows business. And it's something I really wanted to do, to create a team of people that are very diverse, okay? I've been working all my life just with scientists, and it's awesome, but you don't go as quick and further as you want. I have a lot of fun with these guys. How we wanted to do it is mainly we decided to focus our attention on CubeSat. Pitching technology in this country is hard. It is hard. It is hard to find the money, okay? We wanted to create an ecosystem, we want to create an industry, but the reality is that you need to create a real ecosystem. So for us was, let's start on the education side, okay? Let's focus our attention on education, and not just university education. I also teach at University of Adelaide, and I know that when students get there, it's a bit too late. You have to inspire them when they are little, okay? So I've decided to start working with CubeSat in schools, primary and secondary schools. Because Australia, I don't know how many of you know, but what is called STEM, so involvement in science, technology, engineering, and math, is very low. And it decreased like 30% in the past 10 years. That means that people don't go to uni to study this stuff. And in China and Asia, generally speaking, it increased to 35%. These are just numbers, but tell you that in Asia and China, they're all getting very much into engineering and technology, and in this country, people, they don't do it. And I think it's pretty scary. So for me, it was, hey, let's create a STEM program. And a lot of people thought that CubeSat and space is too complicated for kids, but I didn't agree, okay? So this is what we do on the education side. And I think there was the audio, but it's not there anymore. So, I think we can have it. It's okay. So, what we do satellite kits, something like this one. This is a CubeSat, okay, but it's a bit easier, slightly easier. That one you see in the photo was the first prototype. And we started launching them on a stratospheric balloon. And it was an activity that schools could do. We have done many launches, and students on primary and secondary launched their balloon in space, in stratosphere. These are photos we took from this year. It was pretty exciting. And you know, for me, it was a fantastic year. We had a lot of fun. We involved more than 50 schools, and we are going ahead. And this year, we wanted to change a bit the business model, a bit the business approach, and we decided to launch a satellite in space with all kids experiment. So we're going to launch next year satellites from the space station. So this is with kids, okay? So imagine you are 15 years old, you can actually launch something from space. This is pretty cool. I was launching rockets in a park in Rome. It was good enough. So this is what we do on the educational side. It has been very successful because I think schools, they actually need this kind of activities. So we have a program very much integrated in the curriculum. We work with several companies in Australia, like the Victoria Space Education Centre, that provide us with curriculum mapping and lessons. And kids they get these kits, they work with them, they can launch them in the stratospheric flight. The best experiments can be launched in space. It's good fun. The kids love it, and sometimes they really give funny comments, you know, like, I thought that space is just for astronauts and satellites can be launched just from astronauts and things like that. And they actually can do it, you know. We have launching things with 6 years old. They're amazing. I mean, they can do a lot of stuff. So next year what's going to happen is that we're going to launch a satellite from the space station with their experiments. So there will be 4 or 5. There is a competition, it's called Liftoff, and schools can launch their own experiment. For us was, okay, this is a fantastic STEM program, so it's getting very big. We are getting sponsorship and we're going to make it happening, okay? I absolutely love it and we really have a lot of fun. The reality is that at a certain point, 6-7 months ago, as a team, and this is something you have to do and you will have to do in always your life, okay? Understand how a system, a business system, okay, can be sustainable. How you can sustain your business. In the sense that you don't have to look for little money all the time, okay? We sell kits, so we cannot sustain ourselves. We have been doing this so far, okay? But we want to create an industry. CubeSat have been using for several things in the past, but not much for commercial application. But just because, and it's changing, and I'm going to tell you why, but just because people are in the process to understand how they can be used. For us was really, how can we create an industry that self-sustains itself? We didn't know what was the main application of this CubeSat. We learned it on the way. So last year I've done a lot of talking with potential customers. So that's a different way of working in space. A lot of people in space have an idea, a brainstorm around the table, and they think it's the best fit for the market. And this is something, maybe you don't know what I'm talking about, but in 10 years you will tell me, oh, Flavia was right, you know? We were a technology pusher. No. What we have done this year, try to find the best application. And then we thought our best application is a constellation for internet connection. Okay? So a constellation, SatCom constellation. We started investigating this. We started creating a business plan and see if it made sense. And it actually did. And their numbers looks good, and the business plan looks good. And we are going to the path of private investment. So that's a way, you know, we created a normal STEM program. Sometimes in the rest of the world, they work the opposite way around. You know, a big company is created, sometimes with government money, and then they create a foundation down the path, foundation for community. In Australia, we have to do opposite way around, because sometimes in Australia it's easier to do that. Internet, okay? Internet is a big word, in the sense that a lot of people is jumping in this market, is already in this market. Most probably you know, we are using GEO satellite at the moment. geosatellites are very far, very far. And with 3, you cover the Earth. It's fantastic. It's a business that has been working for many years, okay? And it's not what we call it space 2.0. Space 2.0 means new way of doing space. I mean, one geosatellite, how much does it cost? Do you have an idea? It's very expensive, okay? It's a big infrastructure. And yes, still people keep doing this, but it's not the only solution. You can create a constellation of small satellites, okay? And they work like bees. The difference is having a big bird or having a swarm of bees. A swarm of bees is absolutely powerful. You don't want to get around a swarm of bees if they get upset, okay? You don't. Because they're big. Maybe one bee would say, yeah, whatever. And this is what we have been doing so far with CubeSat, you know, whatever. It's one bee. But a constellation is absolutely powerful, can create honey. The reality is, if you know a big space, a constellation of CubeSat is in low orbit, so the dynamic is a bit different. What we have seen is that it's hard at the moment in LEO to compete with the big guys. You've got niche of market area that they cannot reach, but for the rest they're absolutely powerful, hey? Such a little thing is small, so the power they can produce, it's not much. But what if I've got many, okay? And I break it. Another thing that is interesting is that when you launch a geo, so when everything we use for a geosatellite is there for 50, 60, how many years? Many years, and then you do the orbiting when it dies. So you end up using a bit outdated technologies, and that's normal, that's how it is. With CubeSat, you can change technology every 5 years. Technology are going quicker than space application, eh? What we have seen is that there is a huge market for CubeSat in remote areas. So remote areas I'm talking about remote areas all over the world. So I'm talking about a fleet of 150 satellites on 10 orbit planes can cover all our globe and reach all remote areas. And the way they do it is called hotspot, cold spot. So they actually talk to each other. It's a kind of a linkage, okay? They all talk to each other. And you can have a couple of them. So some of them interlink. So you might have less ground stations. So it's a totally different concept, okay? So now we are looking into remote mining communities. I had a chat 2 weeks ago, and I want to give you an idea. I had a chat 2 weeks ago with this guy in Western Australia. He's got this mining company in the middle of nowhere, and he's got 5,000 employees living there in the middle of nowhere, okay? So he told me that he has to pay them heaps of money because it's hard for them to talk with their families. So they've got kids, wives, lovers, whatever, okay? And to talk with them, they use a fat phone. So what is, he spends 10K a person for that phone. 10K a person a month, okay? Wow, that's a lot of money, very expensive. I had a chat in Canberra with the space office, and they gave me this number that is sitting there and scratched my back. Is it the number of the baby? I'm not sure. But they told me that in Northern Territory, to give internet to regional communities, they spend something like 1 million a year. Okay? That's huge. It's a lot of money. It is normal. Because when you create a big fleet, no satellite, a geostationary satellite constant fleet, you want to get the money. And the money in Australia, where are they? In the cities, not really in the middle of nowhere. Remote areas, such a fleet cannot give you like 3 billion users. You cannot do this. You understand the concept that, I don't know how many of you understands a bit telecommunication a bit, but it's all about power. So if you got a little cube, you got solar panels, you can do all kind of magic stuff, but the solar cells are that one. And the power you've got is that one. So the kind of bandwidth, or let's say data, you can send is limited. But that's fine. This is a niche of market. Even if you've got 50,000 users, these are people that either don't have internet or they spend a lot of money. So if you see the numbers of our business model, they're huge. Antarctica is an interesting, and I mean, here University of South Wales, they all know it, and in Australia in general, it's a fantastic example of geo kind of reach it, or in a very complicated way. So it ends up being very expensive if you want to be there and having internet. People are doing that, hey? It's not just us that, hey, we are awesome, we have. What I've seen in life is that when you wake up, you have an idea, someone else have it in the same time on the other side of the world. That's the way it is, okay? You're not just the only one. So I knew about O3B before coming up with this idea. O3B is other 3 billion. The other 3 billion without internet. 3 billion. It's quite a lot of people, eh? They have created this MEO. MEO, so a bit higher, medium. Constellation, I think they are around 10, if I'm not wrong. And still, we are talking about each of the satellites cost them 100. I think what I've heard is, yeah, something like 90 million. It's still an expensive constellation, okay? That needs a lot of investment. So O3B is doing good, but they are looking for investment. They have to put up a huge platform. They need to put up all ground station. This is what O3B is doing in the United States. Have you heard about Project Loon? This is Google Project Loon. So with massive balloons, so not the one we send the little satellite. We're talking about very big balloons. And you send them all over the world to give internet to everyone. I'll show you some numbers, but we are talking about something like 10,000 balloons. Okay, cover Earth, 10,000. We know that NBN is actually trying to achieve in Australia what we are talking about. I had a meeting with some of the people involved 2 weeks ago. NBN was an initiative from the government, I think pretty amazing. Okay, it was still very expensive. I mean, it's a very expensive space infrastructure. And after 6 months, so we started with this business plan, it was September. And in December, one day I woke up and I read the news, and there is this Elon Musk. Elon Musk is SpaceX CEO. So Elon Musk is PayPal and Tesla, one of PayPal and Tesla founders, so one day he creates SpaceX. I think he owns still 80% of his company, okay? And he wrote in a newspaper, hey, the future of telecommunication is constellation in LEO. I'm like, damn it, Elon Musk, really? He said that. And one day after, Richard Branson, because they do fight, the guys, they like to be a bit, if you do it, I'll do it. Good for them. He wrote, yeah. I had this idea, not because Elon Musk said that, but because I had it, and I think I already invest 10 million in a fleet. They are talking about microsatellite, so they are 100 kilograms, okay? So not 10 or 5, 100. Very powerful, very expensive, okay? It took me a couple of weeks to recover from the news that my competitors were Elon Musk and Richard Branson. I was almost about to give the idea up. But there's I see the numbers, okay? So this is what, for example, Google is doing, Google Loon. These are the super pressure balloons. This is the guy they said, the one you see very big. They're very expensive. They're reusable, but we're talking about very expensive. And 10,000, they need 10,000 to cover Earth. The zero pressure balloons, they last 30 days. There are the CubeSat, and then you can start microsat and geo, okay? Different application, different number, different duration, different money. If you ever, I come from Rome, okay? It's a big city, huge city. And what happened in Italy, I mean, a lot of people, build cars, like Ferrari. It's an amazing car. It's an amazing, beautiful car, okay? If you drive with a Ferrari in Rome, drive you crazy. You don't want to do that. Either you will never get to where you want to go, or they will scratch it because they're jealous, okay? Or they will steal it because you get out, get some money, you will not find it. It's not the kind of place you want to use a Ferrari. If you're in Rome, you use a Vespa. I love it. A Vespa and Ferrari are not similar technologies, eh? People that are making Ferraris, they don't want to make Vespas. And people that make Vespas, they don't have the money to create Ferrari or Porsche. And this is a concept that we actually understand in cars. We do. Okay? You don't go with a Vespa the other way because you are not allowed, and because you're going to take you 10 hours to go from Rome to Milan. And you don't go to Rome with a Ferrari. And we do understand this. And when people ask, yeah, Ferrari, they don't manufacture little Vespa, that's fine. Okay. So people ask me, so why Elon Musk don't do it with CubeSat? And I'm like, why should he? He's maybe not doing a Ferrari, he's doing a Jeep. He's not making a Vespa. So if you actually understand the concept, that space is not different from this concept. It's not. You use things for different applications in different ways. You actually do. And it's hard because we are not used to. So when Elon Musk spoke in Seattle and he said, I'm opening this amazing company in Seattle to build satellites, the first question asked, why not CubeSat? And he said, because I've got money to do microsat. If I've got money to build a Ferrari, I'll do it. Okay? It's a different concept. So what I realized is a different market, and that's okay. What makes the model working is that you can produce more. So you actually, what we have seen is that if at the moment, for example, my seed investment, what we call in, let's say in business-wise, a seed investment, so the first phase. If you want to build 2 satellites, it will cost you 2 million. If you want to build the other 148, it will cost you something like 8 million. So that's mean when you do things in large-scale production, the cost goes down, but that's normal, okay? And it's something that no one really did in space so far, with CubeSat. It's something that we are investigating quite heavily in Australia, quite heavily. We created last month a space alliance in South Australia to achieve this, to achieve large-scale production of CubeSat. I gave you some number, and I've told you the 150 satellites are 10 million investment. Guys, 10 million. What is 10 million? It's nothing. I mean, I gave you a number before, and I said I was building a micro-propulsion system for, how much did I say? 5 million? 1. So it's a different way of doing business, completely different. And so sometimes we wonder if constellation are the future. A lot of people think so. Okay. One of the topics I was very busy when I was in Europe, beside the CubeSat, was space debris. I was really fascinated by space debris, so I was really busy on building space debris. One of the patents I got is at the orbiting system for space for CubeSat. Space debris will be a disaster. If a lot of people create their own constellation from 300 to 700 kilometers, okay? The reality is that a lot of people don't see this stuff at the moment. They will have to see it because it's happening. You know these guys? So this photo was taken from, I think, the first mission of SkyBox. SkyBox are 4 people in the United States that 5 years ago founded this little company. 3 of them just out of university, propulsion engineers, like what I was when I was 25, and 1 was a lawyer, okay? They found the SkyBox and they brainstormed like we did a LaunchBox, and they thought, our application is HD imaging. So putting on this constellation instead of a transponder for internet, you put a camera, an HD camera, okay? 4 years later, Google bought them for $700 million last year. They're rich. And they take amazing photos. This is what's going to happen next year. So next year, most probably, you can buy Google on your computer, Google Earth Pro. So with $400 a year, you can actually have these images and see them. And these are not the only guys playing the game. by Planet Lab. So Planet Lab is another company, their competitors, same business, so HD imaging. And the CEO became very, very popular for a TED speech 7 months ago, where he brought this little satellite. A lot of people thought, "Oh, who's that? It's a CubeSat, blah, blah, blah." So check it out. It was a very nice speech. If you go to the website, they've got HD imaging of everything. Yes, I was checking, and some of them are absolutely amazing. So these two guys are playing the CubeSat game on HD imaging. And they are both creating constellation on around 150 satellites. Around 600 kilometers. It will really depend on what's going to happen with the space station. Space station is there, eh? We don't want to interfere with it, but they say they most probably go to retirement to 2020, we'll see. What is interesting, and what will be the advantage of a guy called Elon Musk, is that on a 10 million fleet, more than half is to launch them. Launch, CubeSat, it's very expensive. What these guys do, and most probably you've seen this already, or maybe not, they are the first one that actually launched it from the space station with nanoracks. So you see the big nanoracks addition to the space station and these little things going out. It's a beautiful photo, check it out. They're spending money. Cost a lot of money to launch a CubeSat nowadays because it's piggyback. It's piggyback. You don't want to interfere with a big satellite. You've got a lot of restrictions. You're gonna go up and most probably stay there for how many years? 3, 4, maybe less, it depends, okay? Our goal, ideally, is to put all propulsion system on them. It just extend quite a lot the lifetime of this constellation, up to maybe 10 years. You don't want to extend it too much. I mean, you want to change it. Now we are talking about what we call Ka band frequency. They're pretty packed. In the sense that you need to allocate your frequency is not so easy. What's going to happen if we invent something different, you know? Phase array antennas, V-band, I don't know, just name it. 10 years, you can actually change your constellation. Okay? With a propulsion system, you can access, you know, have what it calls station keeping, and then the orbiting. And then it's done. It's going into the atmosphere, and you don't care anymore. Okay? It's not, it's gone. Most probably this is the same direction where these guys are gonna go with their system, you know, or propulsion system. I'm pretty confident of that area because it's my area, so I'm looking forward to that. But what's gonna happen is there, and this is, I don't know if you guys were there, but there was an amazing CubeSat workshop 1 month ago here, and a lot of people talk about CubeSat, launch of CubeSat, where the price will be really reduced. And that's really where we want to go. It's been one intent here, and it's hard to create such a business in Australia. That is pretty rewarding. You don't have to do the mistakes to push it, so you need to do a lot of analysis. For the STEM area was easy because the reaction was beautiful from the community and anyone, because everyone loves space. Okay, so that one is taking over, and I really hope to launch a satellite. It will be a worldwide first. I mean, ArduoSat is our competitor on the STEM education. So what people do in Arduino, the little chips, they create a similar program in the United States. But that's good. It's a STEM program, so we are happy that everyone comes with this idea. The commercial side of it is the big deal. And there are several things happening in Australia. Maybe you know, maybe you don't. It's not just us doing CubeSat. In South Australia, there is a company that is now wants to create a launcher for CubeSat. In New South Wales, a lot of that's happening, quite a lot. In Canberra, a lot is happening on the science side of it. So they are spending something like 10 million on science. That's also important. We are a bit on the commercial side, because for me it was at least for this company. So we got two companies. One is a foundation, one is LaunchBox Space. For me, was really to create an industry. And the potential of these things is huge. So last month, I've been in geoscience, and because they knew about this constellation that we want to put up for the internet, and they're asking me, do we have space for something else inside the CubeSat? We are planning to use a 6-unit, 12-unit CubeSat. It's still an nanosat. Half of it will be, let's say, with the transponder and the bus, and the rest is open for ideas. It's a big, big commercial advantage if you can create vertical services and give other application a possibility in the constellation. The discussion we are having with geoscience are two, and the typical discussion you have on emergency inside in Australia and the rest of the world. Tsunami monitoring, that I love it. I love the tsunami monitoring application, and fire monitoring. And the big deal there is that there are satellites doing that. Australia, we don't own our platforms, our satellites. So I'm having I had this discussion with geoscience, and they told me, hey, do you know that we spend most of our money to actually ring people to look for data when something happened? There was this big fire in Adelaide 6 months ago, and I think the guy spent 2 weeks with someone at DSTO to find the data from someone in the United States. That's normal, okay? So what's the advantage of having an Australian fleet? I think there is. I think, not everyone sees it yet. We will do it anyway, with our commercial approach. Government knows what we are doing, they're very supportive. And if you can stick a camera and have emergency help, you can stick something else, I'll be happy to do it. Another conversation we are having is with banks. A bank wants to have their data in a secure place. It looks like they're thinking space is the best place, okay, to secure this data. Kind of iCloud for banks. There are a lot of applications, and it's funny to have, I think it's good to have a satellite that's half empty, so let's stick in what we want. This is what we are doing. It's a lot of work, okay? I like it though, and I think it's gonna work out, okay? I have 5 months to make a lot of things working, and then my payload will arrive. That's even harder, I promise you. That's the hardest things you can have in life. It's complicated for 6 months. It's even more complicated a company, but this happened everything in 1 year, okay? I'm a smart person, but not the smartest in the world. I just did it, okay? And I keep pushing, very resilient. And someone told me, Australia, you just have to be resilient. Don't give up. I have my moments, okay? So, that's it, guys. This one is one of our kits for the balloon launchers. This is for the schools. This is 3D printed, very easy. It's 1 unit. The concept is, so the goal when you go in stratospheric is really to measure some stuff and take photos.
Are you continuing that?
Yes.
Right.
We do 10 launches a term, school term. Now we're organizing a launch from Woomera with all the schools in the area. I'm looking forward to that one.
With the kit, how much does the school actually put together?
So what the schools do,
Like what do they get? You supply the kit, but how much of it actually has to get assembled? Like are the ICs already on the boards, or?
We supply 2 kits. This one is for the balloon launch, and there's another one that I didn't bring here, that is for the space competition. So with this one, so what I really want to do with the kit is that both of them comes with lessons. So the students have 7 lessons here, 6 lessons there. With this one, what they do, they install the sensors, they make them working with the Arduino-based chip, okay? This is just a battery. Because one of the issues that you've got in space is the battery for the camera, they die. So we put it here, and then we put a full protection, so they are warm enough, okay? In 7 lessons, they have to do everything. They have to program it, They have to study the path for the balloons, so a safe launch. They have to do all kinds of testing to see if it works, and we've got several testing. Then there is the post-data processing. So it works pretty good in the sense that we always have a test at the end of, so it's chemistry, physics, we touch a lot of areas, okay? We prepared it with VSEC, so the Vettori Space Education Center, and it worked pretty good because they actually touch a lot of areas. Some schools, they 3D print this one. It's not very complicated, it's 4 legs and a top. The other kit is the one they use for the competition. So it's a 0.5 unit. It's got a microcontroller. It's a kind of portable unit in which you can actually attach the sensor you want. So in the competition, we have, I think, 4 areas, like attitude control, communication, innovation. You can come out with your own idea, and and they can actually attach all sensors, attitude control. They can actually attach all the sensors and create with a breadboard their own configuration, okay? This one is more, let's say year 9 to 12. When it's primary school, they just get the camera, they can attach anything, like a little weather station and things like that. So we tune into different years. And the other one is more, we created the other one because what I understood from schools is really depend on what area you are, what kind of teacher you are. It's hard to give something very complicated. So the competition, I mean, the fact that you give, hey, I'm giving you a satellite that got, you know, a brain, a battery, and you do the rest. It really depends. You know, they can come out with an amazing attitude control system with wheels, or they can come out, hey, I put an iPhone and what data from space is fun. So the kids work pretty good. But for me, it was really good giving the educational package with it, because a lot of people give just the kit. You assemble it and good luck, you know. And I've noticed that students don't really care.
Yeah.
While we have web seminars for the teachers and things like that.
Is your student satellite program, or the undergraduate high school student satellite program, distinct from your internet satellite program? And if it is, are you planning to test any technologies for your 6 to 12 unit satellites on your smaller satellites?
I like the question. It's very smart. One of the things, the way we put, it is very smart. I'm going to tell you why. Because when we put the satellites on orbit with the liftoff mission, so with the educational mission, it's a sponsorship based. Okay, so we get sponsorship and we can launch it, because schools can pay $200 for a kit, but they cannot pay for a launch of 200. Okay, and while the other activity is a bit more private investors based, but the reality is you need to think further. Okay, so when we're going to launch liftoff, we will test. I mean, we are launching a QB50 satellite. Most probably you know that QB50 is already launching with the University of New South Wales. Yeah. So most of the bus will be that one. So this first mission was like, hey, we got a bus. Liftoff most probably will have some technologies, because that's the way you have to do it. Yeah. Okay, so it's a very smart question. So it will help us, you know, in the future to use those technologies. Yeah.
My question is actually, how far you done on the propulsion system which attached?
So the propulsion system, it really...
how much you've done? I mean, has been realized or implemented?
Not in LaunchBox, okay? So the QB50 mission has gone on propulsion system. Liftoff mission was probably the box one will not have it. It will start from further on. There are a couple of companies doing propulsion system in Australia, not many. Some activities in here in New South Wales, some activities in Canberra. They're what are called plasma thrusters. Plasma thrusters are the easiest, more simple, less complicated you can get. Okay? I'm now writing a chapter on a nanosatellites book, and I was the one from the propulsion system. Awesome, fantastic. I still need to finish it. I've got 3 days to go. Okay, there are 55 companies around the world, 55 companies, and 20 universities building propulsion systems.
Because I think that's probably the future of this. As you know, Lord Abbott, which so much garbage there. I mean, you end up with, if everybody landing there without smartly covering all that,
Absolutely.
you end up with like a shopping bag thing. But also, it's not because cheap. You're not going to put more sophisticated control system to maintain the life. I think that's probably more important. And because for temporary imaging, now drones, everything, I mean, become a competitor. Really, they can get highly, like a disastrous area, they can send them. Unless you have a mid-age, very cheap
Solution and more
yeah,
longer. Absolutely,
space, that will be
absolutely.
really sustain the life is essential. I think.
Absolutely. I mean, drones are a competitor in the sense that I think people
They're
don't see
quick,
the potential.
temporary.
Exactly.
So not
I had a
that
chat
much.
with this, let's say, CEO of a company in Siberia, oil and gas company. So they've got a huge platform. And what a platform, like oil and gas platform, they use drones to supervise what's happening on the, it's like 50 kilometers huge, it's huge, okay? So he told me we like them, they're solar panel based, so, but you know, we need someone always to retrieve them, put them up. So if you have a solution that is constantly dumping information, just not like that. If you have a satellite solution that is got a brain itself, this is what we want to do. Something like, I pass, I don't see anything, so I'm not dumping to you information, and suddenly I dump
Satellite
information.
is really
Exactly.
critical.
So,
We replace that.
so if you can replace that, it's good. Plasma thruster nowadays costs 10K. So one of the most advanced one is in UK, it costs 10K. The problem with plasma thruster in general, that propulsion system is something that really adapt on your mission. It's really, it's a careful field. I mean, it's not as easy, okay? So you can use a plasma thruster, but that one, if you want the orbiting, it's a pretty difficult concept, but it's the future. You
Yes,
know?
yes. I really so say all the mini quadrocopters, all the flying other objects because smaller, smarter,
Exactly.
front end actuators. So that becoming possible for satellite technology. Because
Exactly.
I'm in control, so more interested in that part. I believe that would going to help for for whatever
Exactly.
nano satellites to survive long. I mean, to prosper,
Survive.
basically, not to prosper, not to
Survive
survive.
long, survive one day. The
To survive
reality,
longer in space.
longer space, when you have a constellation, you actually want to point the constellation.
Yes.
If you have 150 satellites, and finally you need a defense asks you a deep of communication in Afghanistan because they need it, you want all your satellites to point there, okay? So you need a very strict tactical control system or a propulsion system that can help you because you want the best out of the constellation. But this can be done. I mean, I'm doing this research for the book and I've realized a lot of people is working on that. And it goes from a cool gas thruster, you know, to an ion colloid engine that can bring you to the moon.
There could be nano-cubic space station in the future.
Yeah, absolutely.
Yeah.
I mean, the
Long-
conversation
long
I'm hearing are even more complicated. Something like you have a 3D printer in space that, so you don't launch the CubeSat, you produce it in a 3D printed station in space, they launch it. So the things that will happen in 20 years, I'm looking forward to seeing them, honestly speaking, you know? And you know, all this mining, like the mining of the asteroids. I mean, like I just saw remember this is a deep space mission, but you can do mission to Mars with a CubeSat, ideally, if you've got a propulsion system. So the NASA cast of this year, so NASA every year they do also competition, is the fleet of nanosatellites around the moon. And the trickiest part is the propulsion system. And a bit of communication, but the propulsion system is their thing.
Great.
I'm just interested in the high school projects that you've been doing.
Yeah.
The whole area of getting approval with CASA and etc., things like that, how have you approached that?
It's not bad. I mean, when I started, they really scared me about CASA. They're like, oh, it's not gonna happen, and CASA is very complicated. Maybe because our application is pretty good. I don't know. I had my approval for CASA after one day, the first time I did it. I submitted quite a lot of paperwork.
So you did it for the
I'm a
whole
rocket
project?
scientist, so I was like, okay, let's bring it on. So we were in South Australia, for example, we launched from Mount Barker. There's a bit outside the city. So what I did the first time, I really submitted 15 pages of calculation, and the guy from CASA did afterwards, so fine.
So
And
is it an ongoing
It's an
approval?
ongoing approval, but with the same application, so every 2 hours, after 2 hours, I say yes.
Yeah, okay.
When you apply, it's always the same system, but the critical part of launching balloons, in balloons related, is the weather.
Yeah.
So when you give things to CASA, it's usually 2 weeks up front, and you cannot really see how the weather is going to be. But they actually work with you. So 3 days before, if you say, hey, I cannot launch on Saturday, can I launch on Sunday morning? I think most probably it is how competent you are or professional, secure about what you're doing, because we never had an issue.
Yeah, but who's actually doing that? Is that the school you're leading?
No, I do
You are.
everything.
So the school is doing it through you.
The schools, I do all the
That's what
transition.
it's-
Oh, yeah, absolutely.
process, yeah.
It's a logistic that you don't want to
Yeah.
put on the schools.
No.
So all the balloons. So we launch the schools together. So because it's better. So sometimes we have like 4, so all the cameras can see around. Or on top, we can go up to 8. We do everything.
Yeah. Okay, that makes sense. Okay.
All the CASA, all the organization of the balloons, so they don't have any trouble.
So you said your competitor was Elon Musk, and you also said that his satellites, the micro satellites, are more expensive than yours.
Yeah.
But at the same time, he's flying them, he's orbiting them at a high altitude,
Yes.
and hence with less satellites, you have more coverage. And I'm just wondering, so isn't that the same as your constellation? Because you have more satellites, hence you have high costs for the same coverage. If you see what I'm trying to get at.
So what you're trying to say is that he launched them at 600 kilometers, not so high,
Okay.
600, 800. So, still,
Okay.
so he still launched them on LEO,
Okay.
okay?
Okay.
So we're talking about 100. I don't know why Elon Musk always talk about 700. The first time we were talking about 1 pound. I was like, whoa, that's a lot. I think you get to a point that they're on orbit planes. You get to a point when you saturate yourself. I mean, you are covering everything, so I don't think 700 are necessary anyway, so it will be something around 100. So it's still LEO.
Okay.
It's a huge spacecraft with a lot of solar panels, with a fantastic propulsion system. It's not small, but it's big. So they actually have more capabilities. But it's a big platform.
Yeah.
So if you have a big platform, very expensive,
If you want to pay for it, you pay for it.
and at the end of the day, the final cost gets on the one that buys internet. Okay? So if the one that can pay for me is in Sydney, you pay me in Sydney.
That's right. Cool.
It's the idea, but it's still a LEO constellation. 700. Quite a lot. Thank you guys.
Thank
Other
you.
questions?